Hi everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about various types of data presentation. So, when it comes to the part 3 of this data presentation, we are going to see about what are the various types of diagrams that are available for representing the data. Okay. So for that, what we're having here is line graph and then pie chart, bar graph like this. So see, the very first one is that the pie diagram. So pie diagram able to represent the discrete data of qualitative data. So normally the data is going to be classified into two types, what I said previously, and those things already covered in the previous videos. And the data normally classified into two types like qualitative and then quantitative. So quantitative means that we're unable to measures the data, and quantitative means we do not have any no measures at all for the data, right? So for this, the pie diagram is going to be used for qualitative data such as blood groups, age, RH factor, social group, in a population, etc. So normally some of the previous graphs what I said in previous videos were able to cover some of the measures of the data like weight in kgs and then height in centimeters like this. Normally this pie diagram able to represent the discrete data, okay, what we called as a sector diagram, and this data is going to be used for the data which is not having any kind of measures like blood groups, age factor and the knowledge factor, social group and population. Normally the frequency of groups are going to be shown in the form of a circle, and degrees of angle denote the frequency of the area of the sector, and it should also give the comparative difference at a glance, and the size of each angle is going to be calculated by multiplying the frequency or by the total frequency. Normally the size of this angle is going to be measured, that what we called as a degree measure, that should be equal to the frequency divided by the total frequency multiplied by 360 degrees. So this pie diagram able to represent the discrete data of qualitative data such as blood groups, age, RH factor, social group. And these frequencies of this group is going to be shown in the form of the circle. And by make use of this protractor, what we have to do, we have to calculate the angles of the area of the sector. And through the pie diagram, what can able to do, you can able to use the very comparative difference at glance, and each size of angle is going to be calculated by frequency by total frequency, that should be multiplied by 360. So let's see the example how we're going to construct for a pie chart here. So normally you have a table like this. So one column represents the expenses and amount in rupees I'm going to represent it. So normally that any person normally going to have some of the expenses like rent, grocery, transport, current, school fee, and then savings. And so normally the rent will be some 70,000, then grocery it will be 3,000, 8,300, current school fee and the savings like this. We are having the data. So for this data we have to construct this pie chart. So how are we going to construct this means, so make a circle and then represent this in the form of a pie chart, right? Let's take this maybe 7,000. Let me, I'm considering as let me how much of the total amount should be, that should be 47% here. I'm denoting, and then out of this grocery I'm representing 20%, and transport is 5%, current school fee and savings like this. So for this, make an angle of 47 degrees here, 20 degrees, 5 degrees, 2 degrees, and then 13 degrees. Like this we can able to represent the pie chart of the different colors, so that it should be able to see what is going to be secure more expenses in our day life. The person can able to understand very easily. Similarly, if I'm going to consider the another employee of the same data, right? So what will happen, so same picture may also appear. By seeing that, I can able to compare the two expenses of the two employees very easily. So that is the advantage of this pie chart. Imagine that we have four people of survey of friends to find the kind of movie that would like to best here. So a comedian likes four people, action will be five, romance, drama, and sci-fi like this. So I can able to put all the add up of all the data. So let it be 20 here. From the 20, I'm going to calculate how much percentage that I'm going to calculate. Divide with the 100%. So normally comedian will be 4. So what are the total will be 20. That should be divided. 20 means I can able to get 20% here. Similarly, the number of people going to like action movies like this means it should be 5. That if I'm going to divide with 20, then I going to 25. So similarly, romance 30%, drama, sci-fi. So totally that should be equal to the 100%. So once that one is done, we have to be divide with that angle. How much angle I have to construct that. So that is the question I am getting. So for this, once I can able to get this, so 40 by 20 here, that should be multiplied with the 360. Then I can able to get the angle here. So similarly for the action movies, the number of person people are 5. So frequency is 5. The total frequency is 5 by 20. That should be multiplied by 360. Then I can what I get the value that should be 90 degrees. So similarly 108, 18, and 72. So by make use of this protractor, we can able to construct the angles of pie chart for this diagram. So finally can able to get this one. So first one. So here protractor make an angle of 20 degrees. So this should be the 20 comedy represented. And then when it's 25%, there should be action. And remaining 30%, what I have should be this romance. And their drama will be 5%. And sci-fi movies will be 20%. So by making use of this protractor, I can able to construct this. And next one is that bar diagram. So the bar diagram able to consist of rectangular bars of equal length, and these bars stand on some common baseline with an equal gap between one bar to the other bar. And the bars may be either horizontal or vertical, and the bars may be constructed in such a way that their lengths are going to be proportional to the magnitudes, and should also the space between the two consecutive bars should be equal, and all the bars should be of equal width. Okay, so next one is the bar diagram. So for this bar diagram, you can able to construct the rectangular bars of equal width, and this all the bars should be stand on a common baseline with an equal gap between the two bars, and these bars can able to represent in horizontal way, or it may be represented in vertical way, and these bars are going to be constructed in such a way that the lengths are going to be proportional to the magnitude. and the space between the two consecutive bars should be equal, and all the bars should be of equal width. See the example here. So I'm taking the type of school suppliers on x-axis, and the number of students I'm going to take on y-axis. So I would like to know that. So how many number of people are going to be use pencil, and how many number of people are going to be use scale, and a number of peoples are going to be use pen, sharpener, and eraser. I would like to know it. So by seeing this, so this is the bar I have drawn. Suppose the number of students, 8 number of students are going to be use this pencil. Then I have to draw this. And similarly, if the number of, so 3 number of students are going to use the scale, then I have to make use of this. And similarly, how many number of students? So 2 people are going to be use pen. So this one. And then similarly, the 5 number of going people or students are going to use this sharpener. Like this, I can able to construct the bar should be of equal width, and space should be between the bar should also be equal width, and all the bars should be standard and a standard baseline. Normally, this bar diagram will be of different types. So, like simple bar, composite bar, multiple bar, like this. So, if I'm going to take the simple bar, so it is normally this one is used to represent when the item has to be compared with regard to the single characteristic. Okay, so some of the bars are going to represent a rectangular fashion of the width equal height and width to the magnitude, and this normally all the bars should be drawn on a common baseline of equal distance between the two consecutive bars, and these bars may be shaded. So I'm taking this another example, an year on x-axis and the number of dollars on y-axis. So let it be, so 350 of the people are going to be used this dollars in 1992, and 1993 should comes increases by 400, and again it goes on increases by 550, and 600 number of dollars are going to be used on 1995, like this. So I can able to construct by simple bar of the different colors. And subdivided bar, what we call it as is component bar or stacked bar or proportional bar. So here, so normally the data items have whose magnitude is going to be divided into 2 or more components. That means that uh, where the each bar is going to be divided into 2 compositions. So that's why we call it as a component bar, or it may be a stacked bar, or it may be a proportional bar. And the items are going to be represented in the same fashion, like rectangular bars of equal width and height should be of proportional to the magnitude, but here the bar should be divided into subcomponents. And to distinguish the components from one to another clearly, so the different shades are going to be applied, which is going to be described. The shades are going to be provided, and the component bars are drawn whenever the comparison of total magnitude uh, along with the components is going to be required. So this should be the female and composition, and this should be the male composition. So how many number of people who are male and female I want to know in different countries like Pakistan, USA, and Sweden. So the blue is going to represent male people, and red is going to represent the female people. So let it be some 50% of men are available in Pakistan, and this should be the shaded color, and some 55 under 55 should be the female, that should be red color. So similarly in USA the male composition is more, and this should be the female composition. And similarly in Sweden this should be male composition and this should be the female composition, right? So like this we have to be construct the subdivided component bar or stack or proportional. And next one is that percentage bar diagram. So what should be here is that the size of all the bars should be matches with the 100%, and these bars are further divided into different sections of different categories. Okay, so this one is going to represent the magnitude for having two or more components here. So previous one simple bar can able to represent only one component, and then component bar at most two of different lengths, and this component bar should be of equal weight, but the composition is going to be different here. So the comparison of the components are going to be expressed as the percentage of total corresponding totals, and this the totals are to be represented by the bars of equal width and height should be equal to the 100, and these bars are divided according to the percentage components, and the different divisions are to be shaded properly, and the index which describes the shades is going to be provided. So by seeing this, so let's take an example. So now how many number of sales that we should be for hardware, software and services, I would like to know that. So in x-axis I'm going to take the days, that is Monday, Tuesday, Wednesday, Thursday and Friday, and along with y-axis I'm taking how much of percentage of sales for the corresponding hardware, software and services I would like to know that. So for that what we have to do, so let it be some 35% of services is done on Monday, and 30% of softwares are by purchased, and 34.4% of hardware is purchased in the month of in the day Monday. Similarly, the same they have to find out. So how many number of services, number of hardware, number of software that should be available on Tuesday. So like this, I can able to make the composition of bar diagram, what we call as percentage bar diagram. And next one is that multiple bar diagram. So here we have to maintain more than three different variables I'm going to maintain here. So when there are two or more different comparable set of values or multiple bars are going to be drawn, and the set of rectangle bars of equal width with height proportional to values are going to be drawn, and the bars corresponding to the same unit are going to be placed together that should be adjacent to another, and the diagram is going to be shaded properly and index is going to be provided. So let's see the example for this multiple bar diagram. So in day one I want to know how many number of vegetables that is going to be sold in Frank's farm stand. Okay, so let it be, so corn I want to know. So for the single attribute, so what should be the sales on different days. That means that the blue color is going to indicate one day, and two red color is going to indicate the 2 days, and the third 3 days is going to be represented by the green color. So if I'm going to take this corn here, so in day one, so let it be 50 number of corns are going to be sold, and in 2 days it should be 65, and 3 days it should be nearly 69 something. So by seeing this I can able to understand that which vegetable is going to be sold more in quantity. I can able to understand. Suppose if I'm going to take carrot, in one day it should be more, but in 2 days it should be becomes dull, and 3 days it should be becomes dull again. So that means that the carrot is not going to be sold in number of days. And similarly, if I'm going to take the tomatoes in first date, it should be some 45, in second date should be 55, and third day it should be 65 or 60 like this. So that means by seeing this, I can understood that the tomatoes are going to be sold more in number of days. And next one is the deviation bar diagram. So what should be this? So the deviation bar diagram is going to be used for representing the net quantities, so which have both positive and negative values. And the positive deviations are going to be represented by bars above the baseline, and the negative deviations are going to be represented by the bars below the baseline, right? So that's why we can't able to call it as a deviation bar. So for some of the variables, they may have positive values or they may have negative values. So for the positive values, we have to represent the bars above the baseline, and for negative values, I have to represent the bar below the baseline. So in 1985 to 86, I would like to know what should be the sales percent and net profit percent I want to know. So that means that in 1986 to 87, the number of sales is 614%, but the net profit becomes negative here, minus 20%. So that's why I have to represent this bar below the baseline. So similarly, in 1987 to 88, the percentage of sales will be 12% and net profit will be of minus 10%. That's why I have to represent the bar below the baseline here. So what are the other types of graphs? What we have should be stem and leaf graph. So here the stem and leaf graph means, so among the values, so the first value is treated as a stem here, and the second value should be treated as a leaf here. So normally, so this stem and leaf plot is going to be a efficient way to organize the large amount of data here, and is a special kind of table where each data value is going to be split into leaf. So usually a last digit, and the stem that should be other digit is going to be considered, and these stem values are going to be listed down, and leaf values going to right or left from the stem cells. So normally this stem is going to be used to the groups the scores, and each leaf indicates the individual score within the each group, right? So if I take the example like this, we're having the set of data. So if by identifying this, so by set two digit number, so I have one stem and two are the values, so I'm going to consider the set two stem, and three is another, so three another stem, and four is the another stem. So for this stem 1, so what are the values that are associated with 1? So let it be 15. So 1 should be the stem and 15 should be leaf and 6 should be leaf. For the stem to 1, 3, 3, 6. So 1, 3, 3, 6 and 6 should be the leaf values of the stem. And similarly 3 if I take, so what are the leaves should be 0 and then 2, and for 4 it should be 1. So like this I can able to construct the stem and leaf graph. So other type of diagram what we're having is scatter diagram. So which can able to shows the relationship between the two variables, and the dots normally represented as a cluster surround the straight line shows the evidence of the relationship between the linear nature or not. And if there is no cluster, there is no relationship between the variables, I can able to find out. So similarly in x-axis I'm going to take the income values, and then and metro health index I'm going to take on y-axis, and by seeing matches the value what I can able to put the dots what we call as scatter plot diagram what we see. So if I'm going to draw a line, so the values that are linear in nature can able to identify, and some of the dots that may be appear below the baseline or it may be above the linear curve. So these are the some of the diagrams what we're having for representing this what types of presentations. So in the very first one, what I'm going to represent it should be the pie diagram. So this pie diagram is going to represent the discrete data of the qualitative data, and by the angles are going to be measured by frequency, by total frequency that should be multiplied. So this is the example that I discussed in this video, and by taking an example, so how we're going to calculate this degree of angles, degrees, I want to find it out. So for that, what you have to do is you have to first calculate the frequency that should be divided by total frequency. So the sum is going to be find it out, and from that sum you have to that should be multiplied with the 360 degrees. Then you can able to get the angle of the pie chart. And similarly, you have to construct the pie chart. And bar chart is the thing. So we're able to represent the different bars. We have different types of bar diagrams like simple bar, composite bar, multiple bar, and uh, percentage bar diagram. Like this, we'll have different types of graphs also available for representing this. And deviation bar is the another variety that can able to show the relationship between the positive deviations and negative deviations. So if it is a positive deviation, then bar is going to be represented in above the baseline, and if it is the negative deviation, then the bars is going to be below the baseline. So some other type of graphs that may also available here is that stem and leaf graph. So this stem and leaf graph means, so for the values, so what the first digit should be considered as the stem, and the remaining thing what we are having that should be considered as the leaf here. So scatter plot is another type of graph what we are having for showing the relationship between the two variables. So if the dots cluster, that means that the group of dots having the similar nature, then it should be considered as the one cluster. And similarly, this I can able to have one cluster. That will be C1, C2, C3, and entire thing I can able to consider C4. So the dots which are near to linear line should also be considered. That is going to be having no such relationship that can able to exist if that the dots that are lying outside of the cluster. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.